In the keynote lecture session, we will have a speaker, Funamori Sensei from National Institute of Informatics, and the lecture title is Open Science, the Merge Board, the Changing Nature of the Academic Sphere. Funamori Sensei, if you get ready, please start.
Yes, thank you for your kind introduction. I'm Miho Funamori from the National Institute of Informatics. And so I'm going to share the screen. Okay, does everyone see the screen?
Yes.
Yes, okay. So let's start. Thank you for inviting me. I'm Miho Funamori from the National Institute of Informatics, and today I'm going to talk about open science. And maybe you have noticed that the Japanese Cabinet Office is pursuing the open science policy. And this open science policy is asking you several things. And these are quite not really understandable for researchers. It is asking first, there is an immediate open access policy and open science policy. And as for the immediate open access policy, they are asking you to put your research article to register the research article with its underlying data on the institutional repository right after the publication of the article. And many researchers are quite puzzled why you have to do that if you have everyone can see the research article on the publisher's website, and why do you need to do that again and post it on the institutional repository? The other open science policy is asking you to write or submit the so-called data management plan upon the acceptance of our research award. And this template of the data management plan is also very puzzling because it does not make sense that the funder can use it, and it is also nonsense for the researchers, him or herself. It is the open science policy is also asking you to make the research data available open on the institutional repository. But you may also think that the research data has many sensitive data, and also you don't want to share the research data because it's your data and you want to publish your research article. So why is that? And so I want to talk about this open science policy, how it came to these kind of policies, and I want you to position this policy and be able to go along with this policy in your own thinking and in an adequate manner. By the way, we have Hirayama Sensei in this symposium, and Hirayama Sensei was the person to bring this open science idea to Japan. And open science policy is much more pursued in Europe, the EU, and it is beginning to be spreading out around the world. So let's start. Just a brief introduction of myself. I'm Miho Funamori at the National Institute of Informatics, 国立情報学研究所, and I work at the Research Center for Open Science and Data Platform. And this Research Center for Open Science and Data Platform provides what we call the NII Research Data Cloud. Because NII, the National Institute of Informatics, is a so-called 大学共同利用機関. In English, it is called Inter-University Research Organization, and it doesn't make sense, the English term, but it's 大学共同利用機関. And it is there to provide services to all Japanese universities in terms of informatics. And you may know SciNet. It is the internet backbone used by all Japanese universities, and it provides a 600 gigabyte internet backbone. And with this backbone, on top of this backbone, we have several services. And at the contents layer, you're providing this NII Research Data Cloud. It consists of 3 platforms. One is the data managing platform, and this is the data publishing platform, and this is the data discovery platform. The data management platform is kind of Google Drive or Dropbox, where you can share files during research with other research collaborators. But it is this Gakunin RDM is distinct, so that you can share it in a very secure form within Japan, and there are the Gakunin institutions which have joined, and all 4 universities in this HIRAKU-Global universities can use it. So I advise you to try to use it, because it is also providing 100 gigabyte for every individual researchers. Now, after you have used this managing platform during research, and if you have written a research article, or if you have some research data to share, you can send this research article and research data to the research publishing platform. This research publishing platform is the so-called Kikan repository, institutional repository in English. And you may have noticed that your university library has this Kikan repository, and there you can post your research output, and it will be shared on the internet. The registered research outputs are harvested by the discovery platform, CINII research, and the data or research articles are made findable through this discovery platform. It is not, CINI has been the discovery service for many Japanese written research articles, but now we are also incorporating English articles and also research data. And if it is harvested here, it is also harvested, it is also sent out to Google Scholar. So if you put your research articles or research outputs on the Kikan repository, you can be sure that it is going to be spread out over on Google Scholar, and that your work will be read by world researchers. This is the basic platform, 3 platforms we are providing. And on top of it, now we are working on these specific functions: data governance function, data provenance function, called Keynote. I don't know the English word for it. It can send out the program codes and package it, and it is sent out from Gakunin RDM to the computing resources, and then the output is sent back to Gakunin RDM. And it also provides Hitoku Kaiseki Kino, where you can make computations in a secure storage, and it is also going to provide the curation function. Now, I told you this in advance so that you know what we are doing. Going back to my introduction, and I'm not working on these platforms in particular. I'm working on research data policy, which every university needs to draft. And I'm trying to position this research data management within the university's workflow. Because my profession is university management and higher education research. And in my prior position, I was working at the headquarters of the university for 10 years, working on internationalization of university, research assessment, and education planning. And so I was working on university strategies. So this is how I tried to form my academic field in this higher education research. And I'm combining this open science and higher education research to make it understandable for researchers and universities to follow this new path. And this will be the concept of my presentation today. Now, I would like to first begin with explaining you how this open access policy and open science policy came about. These have two different roots, but open access is included within open science. And for the terminology, if you say open access, then it means you are making the research publication available open. If you are saying open science in Japan, it means making the research data available. But because research data have contain many sensitive data, such as privacy data or license and so forth, you usually don't make it fully or available open. You make it available open in a restricted manner, and this we call data sharing. And because for research data, you need to manage it properly before making it available open. There is also a strong emphasis on managing research data. This is how the Japanese policies is terming the open access and open science. In Europe, in EU, they have three pillars. One is open access of research publication. The second is making available open the research data. But in addition, they have also they want to make the research communication or scholarly communication open, and so that many researchers across disciplines, across universities, across society, with the society and academia. They want to make this research communication open. And I think this is a very important part that that the Japanese policymakers should also consider. Now, about open access. The background of the open access policy is because of the rising subscription cost of academic journals. You may know that the academic that the subscription kodokuryo is very much rising, and it's very expensive. And some of your universities may not be able to have access to the academic journals anymore. It became 4 times more in the last 25 years. And many Western universities got concerned about it. Japan didn't notice about this kind of rise because the yen became stronger and stronger after 1985's Prada Accord. So this rising of subscription cost was cancelled off with yen becoming stronger. But after Prime Minister Abe introduced the Abenomics, and yen became weaker, and now we are suffering pretty much of this rising subscription cost, and also about the rising ABC article processing charge, which you need to pay when you want to publish your research article. The price is set by the publishers like Elsevier, Springer Nature, Wiley. These are the 3 big publishers, commercial publishers in the world, publishing academic journals. And they are charging this. And if they are charging this price because they need it, then you would think it is okay to pay the price. But in fact, they have a profit rate of 40%. So they are earning very much money from it. And isn't it ugly that that they're earning so much money? You are writing your paper to be read by your academic community, and you are not writing your paper to let the publishers earn money. So many researchers around the world got angry about it, because you are the one to make the peer review, and you are maintaining the quality of the research articles, and then the publishers are making the profit, and the researchers in your academic community cannot read it because it's too expensive. So there has been several attempts to get around it, and in 2002 there was an epoch-making event called Budapest Open Access Initiative. Around 2000, the internet was spreading out and became used by many researchers. So the researchers, the academia, got the idea to share research articles on the internet and get around the commercial publishers. they proposed two methods to make research articles available open. One is a green open access and one is a gold open access. And these are the two styles which is used also nowadays. The green open access is also called self-archiving, and it means that the researcher archives its author's accepted manual after embargo period on the internet, probably on the institutional repository. So I have described in the beginning that our the NII Research Data Cloud makes it feasible for you to post your research article on the institutional repository. So this is how it is done. And but it is very cumbersome to make this work. And so researchers also got the idea, why not make the journal itself open access? So if the journal itself is open access, then everyone can read it. But if the journal is open access, then you cannot get any subscription cost, subscription revenue. And if there is no revenue, you cannot cover the cost associated with making the journals. So they came to the idea to charge article processing charge from the authors. This was a very, very eye-opening idea, or a very big change that you are going to that you are not going to charge the readers, but you are going to charge the people who write. I told you about the author accepted manual, 著者最終稿, and these are the terminologies. When you submit a research article, this is a submitted version. When after the peer review, the research article is accepted. This one is called the Author Accepted Manual, AAM, 著者最終稿 in Japanese. After the acceptance, the publishers are setting the manual and make these biographical metadata onto it, and it is published. The published version is called Version of Record, VOR 出版版. And the gold open access, the open access journals, in this case, it is already made available upon publication here. The green open access, you have to wait until for this embargo period. This embargo period is there because publishers need the subscription revenue to cover the cost for it. So it's around 1 year or half year, depending on the discipline or academic journals. And this is how it works. Now, these two methods have been proposed, but usually all the publishers didn't like it, and they also didn't work with it. But the breakthrough came not from the academia or publishers. The breakthrough came from the citizens. There have been people with very severe ill disease, and these people who are very very, very, very ill want to look for any information to cure their illness. Sharon Terry, it was not hers who was ill, but she had two children who had rare disease, and she wanted to look into the research articles to find some clue to help and save her children. It is on the TED video, and it's very heartbreaking how she is demanding for the research articles to be available open. Citizens, or there have been several people with a severe illness, and they were claiming that research is conducted through taxpayers' money, and that the citizens are investing in academic research. And why should they pay again for the research output if they have already invested in the research to be conducted? And this was discussed at the US Congress, and the US Congress came up with the idea to introduce the NIH public access policy. In Japan, it is called, or in Japan or other countries in the world, it is called open access policy. But because it was a demand from the public, from the citizens, in US they call it public access policy. And maybe some of you who are in the life sciences have already used the PubMed. Any research output funded by NIH is now posted or registered on the PubMed Central. And this is why you can access there anytime and read any research article which is funded by NIH. And it is very much used around the world, and you can see the very benefit and power of these research articles, that it can be used and read by anyone. UK, the Research Council UK also introduced the same policy, and they pursued it with broad open access. So they are paying the APCs to make their research output available open. With these kind of funders and money to make and making research articles open, and it is mandated, Gimuka, so open access grew by and by, and around 50% became open access in 2015 or 20 or so. But there has been also very difficult, a new problem arose. The publishers were objecting to the open access movement in the beginning, but when they saw that the researchers do like open access very much, and that the researchers are paying even for the research articles to be made available open, they were saying, okay, for the journals they are publishing, it is usually it is a closed journal, so not open access journal, and they are getting the subscription cost from the universities, which is usually funded by the university library. But if the researcher pay for their own research article, then they will make that research article open, which means the subscription cost pays for all the journals article, and in addition, there's another revenue stream now to make the research article available open. So for this open access research article, there's a revenue from subscription and from APC. We call this double dipping, nijudori. And so the publishers are earning now more from academic journals. So this made the researchers of academia upset. And Max Planck Institute came up with the idea to flip everything to open access model. They were saying this half-wise open and half-wise closed thing makes it worse. So why not make it fully available open? And this way, for the subscription cost, they are paying 7.6 billion euro. But if you are flipping everything to APC, and if the APC is around 2,000 euros, then it would just cost 4 billion euro. So they were saying we should be paying less if we flip everything open access. And this idea was again used by the funders, by the European funders, and it became the Plan S. And they were issuing the immediate open access policy, what I have described to you. And they were saying that any research articles funded by public money should be made available open immediately upon publication. And in Europe, they were saying it can be either on open access journal, or it can be also made available open on the repository. So either you can choose green open access or gold open access. It's a researcher's choice. People were very much shocked about this idea. Or it was a very bold plan because it wouldn't allow any revenue to the it wouldn't allow any subscription revenue to the publishers anymore. So people watching if they should follow it. And it was announced in 2018 and should be made into effect after 2021. But United States announced in 2022 that they are also going to follow it. And with this announcement, Japan also decided to follow the path and announced to do it in 2023. So that's how we are also now doing it in Japan. The immediate open access means I have described you, this is gold open access and this is green open access. But the immediate open access is right after the publication. So you can make it either gold or green, but this green part should come here right after the publication. But because you are making the author accepted manual for the green open access, several UK universities are asking for the author accepted manual right after the acceptance of your article, because researchers don't know anymore if there's some time in between the publication and acceptance, then you are going on to your new research and you forget which was the your also accepted manuscript. So UK universities ask you already here to submit your article onto the institute repository. Now, and you are asked about the also accepted manual if you are putting it on institute repository, because as you know, you're transferring your copyright to the publishers when you want to publish your work. And so the copyright is already by the publishers, so you cannot, even if it's your article, you cannot make it available open, or you cannot use your article freely. And but for the also accepted manual, because the publishers haven't done any work at that time, this is considered to be yours. The publishers are disagreeing, but it's gray part. So this AAM, the academics or the libraries are arguing that you can use this also accessible manual, which would be on my MS Word and not very fancily laid out, but you can use this as you like. Now, I have described it right now to you. This immediate open access, if you are making it here available open, the publishers are saying it's invading the transferred copyright, which you have already transferred to the publisher. So this immediate open access is very legally very difficult to implement. And in Europe, they have what they call the rights retention strategy. The funders are pursuing the rights retention strategy, and they are asking the researchers to put a CC BY license onto your also accepted manual or AAM or VOR, and you have to put your CC BY license on the manual. And when you submit a research article on a journal, then you are saying any deliverables like AM or VOR, you demand as an author to put a CC BY license on the article. And this kind of demand or the CC BY license, which is put before the copyright transfer, is valid even after the copyright is transferred to the publishers. So the CC BY license is transferred along with the article to the publishers. So the publishers who have been awarded the copyright need also to follow the CC BY license. This is very tricky, but it seems legally that it is valid in Europe, at least. Now, in Europe, they are doing it, and okay, the publishers are very angry about this rights retention strategy, and they are doing many mimic things and try to try to avoid this kind of thing. And if some articles is sent out with this phrase that it is going to carry a CC BY license, then they are saying we cannot accept this kind of article on our journal, or they are saying if you are paying your APC, then that they are going to accept it, and so forth. So the researchers got very confused because they are set by the funders to put this CC BY license from the funders, but from the publishers, you are said that you cannot do it. And seeing this kind of confusion, several UK and Norwegian universities now are also pursuing the institutional rights retention policy as a university. And they are saying if you are a researcher at your university, then any researcher needs to put the research output on the institutional repository. And this is to be read as an employment contract, which is very much preceding the research submission of research article, and that it is going to be valid. So the researchers were pushing very much towards it because they were seeing that the publishers are making just money from the research articles, but research articles are in fact the researcher's asset, and you want to protect it. So you may also consider to pursue this kind of thing. Now, this kind of immediate open access policy, it is circulating the research outputs at early times, and you may also know that there are the preprints, like archive, where you can share your research ideas or research preliminary research results with your other research colleagues. And there are various ways to share your research output at earlier stage. There are also the peer review, post-publication peer review, where you publish your work first and then the peer review is done after the publication. Or there are also the pre-registered reports, where you put your research idea first, or where you submit your research idea first. And if the research idea and the method to do it looks great, this is the first stage of peer review, then you get the right to publish your research even at this stage, and you can do your research and publish your report. And this is good because also the negative results, which doesn't very which is usually not accepted if the research is not well done, or you get a negative result. And there are many research publication biases. So to avoid this kind of publication biases, these kind of new things is evolving. Now, there are also different things. I'm looking at the watch right now, and I see that I'm taking too much time for it. Now, this kind of preference thing, the publishers are looking also into it, and now they are also providing you the preprint services for Springer Nature. It's in review, or while it's under review. And if you have submitted your research article for peer review and publication, then it is also made available open as a preprint on the publisher's site, and it is published. And it looks great, but you can see that the publishers are going to make money from this part also, because the publishers are acquiring these new ventures or services around research, and you may well see that they are going to take away all your research flows platforms, and in the end, you cannot do any research anymore without paying for all these platforms to the publishers. So be aware that there is someone just taking away your money and make profit from your research or academic research. Now, about the open science. After the funders have made the open access policy, they were finding that also research data should be made available, because the research money is much more spent to producing research data and analyzing it. So these have much more value. And if you can share the research data, then you can avoid the duplication of research, and you can also have more interdisciplinary research and so forth. So as an investor of research, the funding agency thought that the research data should be made available open and utilized by more other researchers, or also from the industrial part, like small and medium enterprises. For research data, there is also the research integrity or issue, and you need transparency. So from this kind of viewpoint, the research data needs to be open access. But as I said, because research data contain many sensitive data, you are not asked to make it available open, but it is more about data sharing. And you are asked more about research management, because there is this research transparency or research integrity matter. But in the end of the goal is the research data utilization, and you have always to keep this part in your mind. The data management plan was introduced by the funders, and they are asking you to write what kind of data you are going to produce, how you are going to analyze it and manipulate it, how you are going to store it, and how you are going to share it, and how you are going to utilize it. And they are in the first doing it to make the researchers aware that it is not their own research data, but it is research data funded by the public, the taxpayers' money, and that it should be shared and used much more to serve the public. And usually for research data, it is said that it should be made available open in the FAIR data principles. And the FAIR data principles is saying FAIR, findable, accessible, interoperable, and reusable. So they're not saying make it available open, but it should be just made, it should be just findable, So it is enough to put on the institutional repository that you have certain research data, which you can share if there is some request, and then it's enough. So don't get upset if you are asked about research data. If you just can post that it is there, then it's enough. And if it's accessible, you you just have to say, please send our email to me, and that you are going to share. And that will be your first step. And in this way, you can judge if someone is asking you and if you think it's improper to share your research data with someone like commercial party or so, then you can also reject it. But usually if you are asked or have a request from another academic researcher, then you usually share your research data and have more research collaborations, and this will expand your research sphere. And I think this open science, this notion of open, did irritate our thinking of what we should pursue. And in fact, this open science policy at EU, it was first coined as Science 2.0. And Science 2.0 means there is the digitalization and the internet coming, and they wanted to pursue science, so-called 2.0. If science can be made, if you can enhance or make innovation in the way how you pursue science. But after making a public consultation, public comment, then someone had the idea to coin it open science. And then it was coined open science. And now we are there. But the Science 2.0 does some history. Already in year 2000, UK was pursuing e-science. The Australian people are coining it e-research. EU was saying Science 2.0, which was coined open science. And I think in Japan it would be KQDX. But so you see that people are trying to figure out if research can be enhanced and in a new dimension or pursued in a new dimension and have some new innovation. Because you may have heard about data incentive science, data 駆動型科学 or data 集中科学, and there is now much more data coming out, and it is not just the informatics, even in chemistry or biology, where people are not so good in manipulating data, or even in humanities or social sciences, you're using so much data, and if you can handle it well, then you can extract much more information and make other research. So the data intensive science is also called the emergence of a fourth research paradigm after the experimental science, theoretical science, and computational science. So you can do much more with this. For open science, so you want to utilize the internet and collaboration work. So there is also much emphasis on citizen science, where you work with the citizens and do new things. And for the Europe's open science policy, they are establishing this European open science cloud, where they put many disciplinary data repositories and combine them with several research tools so that the researchers can do any research using these data and these research tools. And S3 is the organization which invests in big research infrastructures like Tenmondai or Oshaku no Shisetsu or so. And the former director of S3 said it is no longer possible or sensible to simply look at the facilities without also considering the data handling. So you need some data infrastructure to handle all the data coming out from these research infrastructures. So S3 introduced a new reviewing aspect, INIs, and if the research facilities has this kind of data handling platform, then they are given more points to be awarded more money. And and I like this NFFA Europe. It is a platform in nanoscience foundries and free analysis. And there are many research facilities like X-ray or NMR or microscopy and so forth. And all the data coming out from these research facilities is, the data is instantly uploaded to the research cloud, and the researchers can, and there are also the research tool, analyzing tools on the platform, and the researchers can analyze the data, and after they have published some research articles, then they can also make the research data available open on the same platform, and other researchers can use the research data. So it is very efficient. And these kind of platforms now exist for many disciplines. And with this, if you are using much more data, then the researchers don't necessarily have the skills to use the data. So you need many more data professionals, as you see here. And in open science in policy in Europe, they are now saying we have to move from competitive paradigm to collaborative paradigm, because you need many people's skills and expertise to pursue your research. And if you are working in team, like team science, then you can achieve much more. But if you are, if you need your research output as a first author to enhance your career, then you would never, you won't like to go to this team science. So in EU open science policy, they are also trying to make reform in the research assessment. And now they have this coalition for advancing research assessment, QUARA, where 40 countries and more than 350 institutions join. And they are trying to assess research from various points, and not just from research paper and citation or impact factor. And Netherlands is the front runner of it, and they want to make reform in the research assessment, and they have this campaign, Room for Everyone's Talent. And Utrecht University announced in 2023 that they are going to withdraw from global rankings, so they are not anymore assessed by the Times Higher Education. And several other universities joined this path. Apart from the research assessment reform, there is also for the research if you have co-authors on research articles, you can also add to your co-authors what kind of role they had. And this is called credit. And if you are looking at a movie, at the end roll, you are seeing who made the pictures, who made the clothing, and who is the director and so forth. And with the same with the movie's end roll, you can put on your research article what kind of role each research your co-authors had. And with these data professionals, the research software engineers are part of the data professionals who are emerging, and they are also making this kind of community to work together. And there are also universities who have some people centrally to assist the researchers' research project. So UCL, University College of London, have 46 research software engineers, 11 data scientists, 16 data stewards, and 30 research infrastructure developers, centrally full-time employed. And if you are a researcher at some department and you have a research project, if you can pay for their work, then these people are dispatched to your research project and you can have their expertise. And this way, many research universities are competing against each other and trying to support the researchers' research work. There is also the attempt to have the GPU and storage provided by the universities. In Japan, many times the researchers themselves need to care about it, but with the rise of AI, artificial intelligence research, if you have the GPU, then you can make the research. So as the university, you want to provide this GPU and storage so that the research can do the research and that the university can pursue the research. Australian universities are trying to use the DMP, data management plan, to grasp how many research resources you need, and they are summing it up and projecting it for storage and research computing resources, and they are providing it to the researchers. Now, so this is the big sphere how open science or research data management is pursued, and it has many issues as I describe it here. And it was in fact the COVID-19 coronavirus which accelerated the open science, because when we had the COVID-19, the research data or research articles or preprints were shared immediately, and we could cope with the COVID-19 in very early stage. And UNESCO has the recommendation on open science, and now open science is coined much more with equity, meaning that they are saying that even the developing countries need to be more able to join the academic sphere, which is much more pursued by the developed countries. So the open science meaning got much more, got a very social meaning in the end. So you see I have described that open science was first coined Science 2.0, and if it had stayed just Science 2.0 or e-science, it wouldn't have made that far. But because it was coined open science and it got a social meaning, it got the research integrity part, research transparency part, this equity part, and that research should be shared with the citizens and social public and so forth. And the open science movement grew much more. But maybe it got with this as a policy it grew much. But as a researcher, maybe you should also focus on Science 2.0 or e-science and see that the research competition is now how to make research more effective in a digital world or internet connected world. Now, because the timing is running out, I had some presentation here, which is more pragmatic, how to follow the open science in for the Japanese government's open science policy. But I want to skip it. I will provide you this material so that you can look it afterwards. And I want to conclude that this open science movement is, along with the changing academic sphere right now, because as you know, the higher education was first designed, has been only by small people, by the small elites. But now, after the World War II, to much more, many people need to join the university to get even employment, a job, and everyone is coming to that, and it is moving to the universal square. And there is a term called massification of higher education or mass access to higher education, which was proposed by Martin Troll in 1980s. And he was saying when the university attainment rate grew and that the student body became not just elites, but university for everyone, the education provided by the university had to change much more. And what I'm proposing is now we are in the second stage, that in the society or in public that there are many people with a university degree and who has the understanding for research and who have the skills to do their research by themselves, and that there is now much more demand also to the research what we are pursuing, and that open science is along with this massification of research. And you may know a university has been very small and ignorable to the public, but with this massification, the public need to fund this university, and if you can get a good job or if the university is providing good service to the public, then it's okay. But there are, as you see, there are many issues, and so people feel you are paying so much tax, but the universities or academia are not providing good service to the public. And so universities need to transform themselves from ivory tower to become some service generating entity towards the public, not just for education, but also for research. And that is, I think, how the ill people demanded for research articles to be made available how it came to the open access policy. And after a while, I think the public is much more able to do research and collaborate with the academia, and you have a much more interesting and innovative world together. With this open science and open access and open science policy, just putting research outputs on institutional repository is not enough or does not make sense. It won't change anything. You have to think something which is going to make it meaningful to you to pursue. And because I think that open science is, along with higher education, changing to be much more together with the public, we should think about utilizing data and having more cross-disciplinary or having more social impact research. And with this, and I hope that you have much more collaboration along with it. And these are several attempts to do it, which I found, and I hope with the collaboration of university and public that we will get fresh idea, and that these kind of fresh ideas will be made more transformed to our knowledge, and that we can transfer this knowledge through the educational programs to the students, and that the graduates will be able to make innovation in the society, and that the solutions will be made stable in the society. And I hope this kind of new structure will begin in the academia. And this is the last slide. You can, as a researcher, you can choose to be the winner in the old paradigm. The old paradigm is the discipline-based research, but you can also try to be a pioneer in the new paradigm. And so I want to close my speech. I'm sorry that I'm running out. I took too much time.
Thank you very much for interesting talk, Funamori Sensei. To organize us, how long should we have? Do we have
maybe
time for
5 minutes more?
5 minutes or something.
Yeah.
So if you have any questions or comments, please raise your hand or write into the Q&A. Okay, let's start from me. For open access is relatively easy to understand for me, because but open science is still difficult to understand it. It's especially for like me as a basic scientist. So what's basic and experimental research, and to achieve the open science world, what should I share to the world, or how, or do I need to change? What do I need to change for?
So you first you don't need to share it instantly with the public. You can also share your research data with your own with your same discipline. And I was quite much shocked that there is an expedition by NASA where the countries internationally put much money into it, and where they get the asteroids from the planets back to Earth, and where the scientists are using the asteroids to make research, and these data are not archived, but distributed around the researchers, and it is faded away after a while, and the researchers are taking it to their after retirement. It's in your hard disk or somewhere, and it gets faded away. And NASA realized it, and just last year they have now started to collect it and put it in a data repository so that it is shared by the research community, and that anyone can use it. So, and I think there are many of these kind of cases where you just acquire the research data and use it just by yourself. But but it is good that you can. It is okay that you may write your research article by yourself, but after you have used your research data, then you can also share it, and maybe someone other can utilize the research data to make other research from other other viewpoint. So I hope this would be something. And NIH made an experiment for some research funding that every research data should be shared from this special research program, funding program, that the research data should be shared right immediately after the research data is acquired. So the research group cannot write research article, cannot make it open up after writing a research article, but should make it available open instantly. And many researchers around the world accessed the research data, and from various viewpoints they were making new research, and hundreds of researchers used it. And the research group who produced the research data couldn't do any research because the cleaning up of research data or organizing it was too much. It acquired too much work. But if 100 people are using it, then we can have much more impact from the same research data. So I see there is some.
Thank you very much.
May I ask a question?
Mm-hmm.
So it's more, I think I have a couple of comments that I would like to make. So my name is Josh Tendeiro, and I'm here from Hiroshima University. And open science is a topic that is close to me for several years now. And I have been trying to share as much of my work as I can. So I really enjoyed your talk, and I would like to add a couple of opinions just to, I think they can probably complement what you presented to us. And in case you disagree with me, I would love to hear your opinion. So the first thing I would like to highlight is that I fully agree that publishers are one of the main problems that opens the way for and I also think that we are the ones that are also feeding publishers. So what I think is that by using impact factors and number of papers to evaluate researchers, we are feeding into the publisher's system. So very much like it's happening in Europe and in North America, I think in Japan, we should start discussing the idea of evaluating researchers in a way that is not so quantitative, based on impact factors, number of publications, and so on. There are other qualitative ways of evaluating researchers, and this will take away from publishers, which I think we should do. Another thing is that for preprints, I really vouch against using publishers' repositories for that. Preprints are meant precisely to avoid publishers. We have a lot of open repositories, Open Science Framework, Archive. So I think we should not use publishers. And finally, sharing data, I would only like to say that everyone should feel almost obliged to share as much as possible for accountability, giving back to society. And that's all.
Thank you so much. And I think it was just in line with what I wanted to say. So.
Thank you.
Yes. I hope we could give the audience today some ideas that we should also think about sharing research data and what it means to us as an academia, and that we shouldn't just work in an old paradigm, but that we could achieve much more if we share research data and research outputs, and that could generate a new world of making research.
I agree. And a world where we are also held accountable for what we do. It's part of opening the research, that people look at what we do. If we make mistakes, if there is a problem in our research, it should be found, because we are being paid with public money. So what we do should be made with as maximum responsibility as possible. And we should be scrutinized in this way. So I actually support sharing all our materials as much as possible, also so that we are evaluated by other research labs. And if we have errors, if we have mistakes, we should be pointed out so that science continues in a good path. And open science fits this perfectly, I think.
Yes, that's right.
Thank you.
And about data management plan, I think data management plan are something that should enable this kind of this, and how we make our research more in a proper manner. And I think the data management plan asked by the funders right now is very misleading, and it should be some data management plan which is also useful for the researchers. And you can, if you are thinking about archaeology or so, if you are awarded a research in archaeology, kokogaku, then you are not just going to the site and start digging. You usually estimate how much there would be to dig and bring home, and you would estimate how many people you would like to bring with you to help your digging work, and you would assign several trucks to bring the material home to the university lab, and you would have some storage and have bookshelves to put your materials in it. And this should be done also in a digital manner, and not just physically. And these are the how you could use the data management plan. And also there's the emphasis on the legal and ethical manner. And many researchers don't like it or don't understand it very much, but we are living a world where we need to be accountable. So we also need to care about these things. And NII is now trying to make a DNPD power tool or data governance tool where you can make these kind of things smoothly. And DMR is a concept which which I'm proposing, because data management plans, it's plan, and in the beginning of a research hour, you don't know what kind of research data you are going to get and how you are going to analyze it, and how you are going to store it and so forth. And it makes much more sense to have the data management records and the history of how you have used your research data to be able to manage research data properly and to be accountable to the public.
Thank you very much. And there is a comment from Harayama Sensei that the starting point of open science is the recognition is that research results are public goods. So then, because of the time limitation, I'd like to close this session and return to the microphone to the organizers.